All right, guys, these are the practice problems that go with exponential decay. So let's start up at the top. A new SUV depreciates, so that's a word letting us know that we have decay because the value is going to go down each year by a factor of 15%. If the SUV initially costs $20,000 when it's made, what will the value of the SUV be 20 years later? All right, so we've got all the information we need to solve this problem. We're just going to put it into our formula. So our amount is going to equal our principal amount times 1 minus the rate of decay to the t over n. The principal amount is what it starts off being valued as, and that's $20,000. So then we have 1 minus our rate of decay. It's depreciating by 15% every year. So the way that we're going to represent that is 1 minus 0.15. Time is going to be 20 years, and since the depreciation only happens once per year, n is 1. This is a pretty easy thing for us to calculate now. We just have 20,000 times 0.85 to the 20th power, and you can just plug that into your calculator. Now, you guys at home don't have your graphing calculators. You should go to a website called Wolfram Alpha. You can plug anything you want into that site and it'll just calculate it like a graphing calculator would. So when you go to that site and plug that in, you get a total value of $775.19. And we can leave decimals now because we're talking about money. We can have 2 decimal places for that. So in 20 years, the value of this $20,000 SUV actually depreciates to be about $775. A very real-world example of exponential decay. All right, the second example says that the attendance for a basketball game declined. That's our hint that we're dealing with decay at a rate of 5% per game throughout a losing season. If they started with 23,500 people at the first game, identify the exponential function that models the attendance of fans from game to game. So first, we're just going to write down what our equation would be if we were to calculate it. We don't really know the time yet, but if we did know the time, we'd be able to start with our principal amount, which is 23,500. We would subtract from that 0.05 because our rate is 5%, and we would raise it to the t over n power. And time would be games, so if it's declining once per game, n is going to be 1 again in this case. And then it says how many fans were at the 15th game. Well, now we can plug this in since we still have a principal amount of 23,500 fans. We plug in, now we have 0.95, 1 minus 0.05 is 0.95, to the 15th power, and it happens once per game. So 15 games later, what are we looking at? That comes out to be about 10,000, and because I'm rounding, 887.344. And since we're talking about people, you cannot have 0.344 of a person, so the amount of whole people that are at that game is 10,887 people. So in the last example, when we were talking about money, you can have cents, so we can have decimal places. When we're talking about people, you cannot have 0.344 people, so you have to round down to the nearest whole number. Last one. Each day, 10% of a specific drug dissipates, and that's a word meaning decays or disintegrates from the system. What's an equation that can be used to model the decay of the drug? So this is a lot like the last example. The total amount will equal the principal amount, which in this case is going to be the whole drug, so 100% of it, 1, times 1 minus 0.10, that's 10%, to the t over n power. And if we're talking about each day, the time is in days, the drug dissipates by this much once per day. So n is going to be 1 for us once again. So how much of the drug remains in a person's system after 9 days? The total amount will equal 1 times 0.9 to the 9th power. And all you have to do is just plug that into your calculator, whatever you're using, and you'll get 0.387 approximately, because we do have to round there, which is going to be about 38.7% of the drug. So if 10% of what's left leaves every single day, then after 9 days, that's how much of the drug you'll have left. All right, so that's a few examples on exponential decay. Now you've got a video detailing how exponential growth works, how exponential decay works, and then 2 videos on examples of each. So you guys should be able to do the homework problems on your own at this point. Good luck, and I'll see you guys after break.